Hit me with your questions here, folks. Yeah, Madison. Can I do number 1? Sure. So, if I wanted to solve this by graphing, I need to graph these equations, right? Notice that these are both going to be equations for lines. So how many points do I need to graph a line? 2. Okay? So we'll start with the first equation. I'm going to just pick a value for x. So let's pick something convenient. Maybe I'll pick x equals 0. I'll plug that in for x, and then find the corresponding y. So negative 2 times 0 is 0, and 0 plus 3y is just 3y. So if I divide both sides by 3, I get y equals 2. So 1 point on that first line is the point 0, 2. 0 is my x, and 2 is my y. Okay with that so far, Madison? Okay. Now, you can pick another x if you want, but since they're on the same side of the equation, we also have the option of picking another y. So why not pick y's and find x's, right? Is there anything wrong with doing that? No, still the same thing. So maybe I'll pick now y to be 0. So when I plug that in, I get negative 2x plus 3 times 0 is equal to 6. Well, 3 times 0 is 0, and negative 2x plus 0 is just negative 2x. So to find x, I can just divide both sides by negative 2 to get negative 3. So negative 3, 0 is my other point. So there's my first line. Okay with that, Madison? Okay. I'll do the same thing for the second line. Notice here, if I pick 0 for x, what's the y got to be? 4. And if I pick 0 for y, what's the x got to be? 4. Are you okay with how we did that so fast in our head, Madison? So there's my second equation. What's my solution got to be? The intersection. If I did that neatly, it should be 1, 3. How could you check this to make sure you got the right solution? Yeah. You can just solve that system using your matrix, right? Just takes a minute or so, and you know immediately what the answer is supposed to be, and if your graph doesn't match that, you know you've made a mistake, and you can go back and look for that. Does that feel okay there, Madison? Okay. Everybody else feel okay on that? Okay. All right. Who's next? What else should we talk about? Tommy. Yeah, do you have one of these problems in particular you wanted to look at? Do 6? Sure. So that's a matrix multiplication problem. Does that work for you there, Tom?
Yeah.
Okay. All right. So we have two options here. I can do it in this order, or I could do it in this order. It doesn't matter. For For the sake of argument, let's multiply just the first two ones together first. Is that okay with everybody? Before we do that multiplication, though, what should we check? We should check the dimensions to make sure it's even possible to do this multiplication problem. So what's the dimension of this first matrix? 3 by 2. And the dimension of the second one is 2 by 2. And the last one is? So is it possible to multiply these three together? Yes, right? How can you tell? Well, the inside dimensions match for the first pair, and the inside dimensions match for the second pair. So we can do this multiplication. Everybody good with that? Okay. So let's say we multiply these first two matrices together. What size matrix are we going to get as our answer? We'll get a 3 by 2. And then I'll just copy that other matrix over here before I forget about it. Okay. So, to get the first entry in my answer, what two things am I multiplying together? Row 1 by column 1. So I'm going to have 1 times 5. That didn't look like a 5. And I'll add that to 4 times 2. And then I'll do row 1 times column 2. So 1 times negative 6 plus 4 times negative 2. And then I'll do row 2 times column 1. So 0 times 5 minus 3 times 2. Row 2 times column 2, 0 times negative 6, negative 3 times negative 2. And then row 3 times column 1, negative 2 times 5, and 1 times 2. And then I have row 3 times column 2, negative 2 times negative 6, plus 1 times negative 2. So far, so good? Tommy, you feel all right there? Caden, you're good? Okay. Yes. Of course, Julia. All right, so let's multiply this stuff out. So it's a 5 and an 8, a negative 6. That gives me a 13, I guess. Let's actually, maybe I'll just write the 13. Then I have negative 6 plus negative 8. That's negative 14. 0 minus 6 is negative 6. 0 plus 6 is 6. Negative 10 plus 2 is negative 8. And 12 minus 2 is 10. Everybody okay there? So now I'm going to multiply these together. Since this is another 3 by 2 times a 2 by 2, I know the dimension of my answer is also going to be a 3 by 2. So to get my first entry in my answer, I do row 1 times column 1. And then I do row 1 times column 2. Then I'll do row 2 times column 1. And then row 2 times column 2. I forgot where I was at there for a moment. And then we'll do row 3 times column 1. And then row 3 times column 2. So when I simplify that out, I'm going to get negative 30, negative 45, 12, 18, 24, 36. on the test, how could you check your work here? You just type in your calculator, right? So on the test, I am going to require that I would see like these steps where you've written out what you're multiplying together to get the answer. I would need to see that for full credit. That's what I mean by appropriate intermediate steps. So I would need to see like how you're getting to your answer, like what stuff are you adding together, multiplying together, or whatever. But you should be able to get the right answer because you know what the right answer is, right? The calculator will tell you. So if you didn't get it from the work that you did, you'd know to go back and check, and you'll probably notice like, oh, look at this, I did row 1 times column 2 when I was supposed to do row 1 times column 3 or whatever. Like you could hopefully figure out like, oh, entry 4 was wrong. Why was it wrong? Oh, look, I did something silly and like dropped a negative sign or something. You know what I mean? Justin. So you would have gotten the same answer had you done this. However, you have to keep the order of the matrices the same. So whatever that answer is, you'd have to multiply like this. You can't put that one over here. That would be bad. Okay, so the order has to stay the same. Okay, you can multiply whichever 2 first that you want, but it's still got to either be the first matrix when it was the first 2, or the second matrix when it was the last 2. You know what I mean? So that's the one thing you have to be careful about. That's why I usually just go from right or from left to right so I don't screw up and copy my matrices in the wrong order or something. Tommy. Yeah, then you just multiply that one. Yeah. Same idea. Are you satisfied with that? Yeah. Sure, no problem. What else do you guys want to see or talk about or whatever? Justin? 15? Sure. So this says to write the system as a matrix equation and then use your calculator to solve that matrix equation. Okay? So the matrix equation starts with our coefficients matrix. So I'm just going to copy the coefficients. That's my coefficients matrix. I'll call that A. And then it has a variable. I'm going to multiply that by the variable matrix. I'll call that matrix X. And that'll give you my solutions matrix. That's matrix B. So that's what I want for the matrix equation. And then what I'm going to do in my calculator is A inverse times B. And that'll give me my answer. So let's do that right quick. That's if we're doing Gaussian elimination. So 16 asks you for Gaussian elimination. I mean, I suppose. Sure. Just waiting for my calculator to load here. Anytime, calculator. Are we going or what? Sometimes this takes so long to load, I just don't understand what's going on. Why it's being such a, like a turtle or whatever about it. Even as a picture of a rabbit on it, you'd think it would be fast. It is so slow. What's, oh, there it is. It's just hiding on me. Why did you not come to the forward? I don't know. It's a good question. All right. So I'm going to go do edit. I'm going to take this first matrix and turn it into a 3x3. We're good at where like all these menus are located, right? Okay. If we're not, please ask and I'd be happy to like show you the buttons again, but we've done this a number of times. I hope that we're all familiar with where the matrix menus are and stuff. And then I'll put my other matrix in as B. It's a 3x1. I'll exit out to the main screen, and I'll do A inverse times B. So I get this, and if I wanted these as fractions instead, I can press the math button and then select the fraction command, and it'll give it to me as fractions. If the decimals don't terminate, yes. So those were infinite decimals. It was like 0.6 repeating. Yeah. So if they end, if it's just like 0.5, you can list it as a decimal. That's no big deal because that's exact. But if it goes on forever, you can't write it down forever unless you put like the little bar over it or whatever to indicate it's repeating. And that would be fine. But just as, like you'd write as a fraction also, and the calculator can give you the fraction, so it's no big deal. You know what I mean? When in doubt, write as a fraction would be my recommendation. If you're like, is that an exact answer? I don't know. Write as a fraction, man. It's no big deal. The calculator will do it for you. If you do know it terminates, like, yeah, just like a 0.5 there, no big deal. I won't mark it down for that. The thing that drives me crazy, though, is when students do this, where we get like, I say we did like 2 divided by 3 equals 0.6. It's like, no, that's not true at all. And I see students do this all the time. It's like, that's 0.6 repeating. That's a whole different, 0.6 is a whole different fraction than 2/3. So, like, that's the thing that just grinds my gears as a math teacher, is when you put an equal sign between two things that are clearly not equal. Anyway, you said we want to talk about 16 also? So the augmented matrix for 16, I just remove all the variables in the math symbols and just take only the numbers. Now, I guess I should make mention that everything has to line up, right? Like the x, y, z equal signs and solutions all have to line up vertically for that to work, which I didn't make mention, but I checked it visually. More often than not, when we give you one of those things, that'll be the case. So then I'm going to do the RREF to that matrix, and the calculator will handle this for me. So again, I'll go to edit, and I'll enter this in. So that's a 3 by 4. Is there a question, guys, or are you just kind of clarifying amongst yourselves? If I did something that you think is wrong or you're not sure why I did it, please ask. That's what this time is for. And I do make mistakes, more than I'd like, but, nobody's perfect. I'm trying, though. Maybe sometime next week I'll get there. It's a joke, guys. You can laugh at them. Okay. And then I'll just do the RREF command on that matrix C, which gives me this answer. Again, probably want to look at it as a fraction rather than decimals. And what kind of answer am I getting here? If I was to interpret this, what is this saying? Good, infinitely many solutions. How did you see that? Because the last row is just zeros. What that last row is basically saying is 0 equals 0, right? 0x plus 0y plus 0z is equal to 0. That's infinitely many solutions. So let's write the general solution then for this. So if I use the first row, that's going to give me the equation x plus or minus 1/3 z is equal to negative 28 over 3. Everybody okay with that? Okay. If I look at the second row, that says y minus 1/3 z is equal to 5/3. Everybody okay there? So what I'm going to do is I'm going to isolate the x and the y, because I can see that I cannot write both of them in terms of z, right? All I need to do is just add 1/3 z to both sides. Everybody okay there? Well, I'm getting my general form. So for x, I'm going to write 1/3 z minus 28/3. And for y, I'm going to write 1/3 z plus 5/3. And then z will be like my independent variable. So this is the general form solution for that infinitely many. That was all for 16, yes. And the only reason this became so complicated is we got infinitely many solutions here. Ordinarily, if you just get like the identity matrix here and then answers, then you can just list off your 3 answers, right? Because we got infinitely many solutions here, there's more for us to do, where we have to give that general kind of solution set. And yes, I would expect that if that happened on the test, that you're able to give the general solution set, similar to what we did here. But it shouldn't be too bad, right? All we need to do is use these 2 solutions to generate our descriptors. Caden? Yeah. Yeah, it was, let's see. We did that, and we got this, which I said probably makes more sense to write as a fraction. So that's, those 3 fractions are answers for x, y, and z respectively. Nancy? Sure. Does that feel okay? Sure. As long as it's not, I don't know, that's fine. Yes. I was going to try to make a joke, but it was a dumb joke, so I just stopped. Tommy? For number 3? So on number 3, I ask you to use elimination. So that's a by hand method. Now, I would certainly start number 3 by doing the RREF on it so I knew what the solution was. So as I was doing it by hand, if I got the wrong answer at some point, I would know to like, oh, shoot, I better go back and like double check my work and look for the mistake. So I would say that 1, 2, and 3 are all by hand problems. Yeah, you're just solving these systems using your by hand method, so substitution or elimination. And obviously these ones are, the matrix ones are ones I expect to see some by hand work. But again, like all of those things so far that we've talked about that I want you to do by hand are checkable, right? You type all those into your calculator, know exactly what the correct solution is going to be. So you can certainly make sure you can go back through your work and look for mistakes if you make them, right? Now these ones on this page, 15 through 18, these are all problems that you do just where I would ask you to show me the setup like we've done here, and then just write down the answer afterwards. Okay with that? I would need to see the work also. You should plug in your calculator so you know what the answer is, but I need to see the work as to how you got that answer as well. Sure. Sure. 5 is the easy one, though, just FYI. So if the determinant is a 2 by 2, I'm just going to multiply this diagonal and subtract it from that diagonal. So that comes out to be 0. Yeah, can we pretend that we did the multiplication? I can just write down what the result is, and we take the determinant of that? Yeah. Okay. With the multiplication? Yeah. Yes. Just like we did in the above problem. I just, in the interest of time and being able to address as many questions as I can, I thought maybe I can shortcut through that for us. So if I want to take the determinant of a 3 by 3, what I do is I start by recopying the first two columns. And now I'm going to multiply the 3 downward diagonals. So 3 times 0 times negative 5. And I'm going to add those 3 multiplication problems together. Okay with that? And then I'm going to do the multiply the 3 upward diagonals together. So then I have, this would all be on one line, but in the interest of keeping things neat, I'm going to write it on 2 lines. Is that okay?
Yeah.
Okay. And then I just go ahead and do that out. So that would be the work that I'd want to see, is that right there. And when I type that in my calculator, I get 0. Madison. Like we just did here. We did 8. I didn't show the multiplication. I asked Tommy if it was okay if I skipped showing the multiplication. But certainly that's something I could ask you to do. Is that okay? Okay. Zach. 7? Sure. I'm going to erase some of this stuff out of my way here. All right. So the first thing we'll do is do D inverse. So remember do you guys remember? Yes, Justin? Sure. Do you remember the formula for the inverse of a 2 by 2 matrix? So this is a formula you should expect to remember. Okay. Yep, 1 over the determinant of D, which in this case is going to be 5 times negative 2 minus 2 times negative 6. Okay. Then what? Good. So we swap the locations on the first diagonal. So if you look at the matrix D, it was 5 and 2 were in the opposite locations, right? Or the 5 and the negative 2, excuse me. Okay? And then the other diagonal, you swap the sign, so the negative things become positive, and the positive things become negative. And then I still have this matrix C here. Zach, you good so far? Okay. Now I have 3 things to multiply together. Would it be easier to do the scalar multiplication first or the matrix multiplication first? I always do the matrix multiplication first because I will get to avoid having to deal with any fractions by doing that. And not that fractions are a big deal, but if I don't have to do them, I'm just as happy not to do them. So negative 10 minus a negative 12 is 2, so that just turns into a 1/2 out front. And when I multiply a 2 by 2, a 2 by 2, I just get another 2 by 2. So if I do row times column, that's negative 2 times 2 plus 6 times 4. And then I get negative 2 times 3 plus 6 times 6. And then negative 2 times 2 plus 5 times 4. And then negative 2 times 3 plus 5 times 6. So when I do that arithmetic there, I get 1/2 20, 30, 16, and then 24. Okay there? All right. And when I do the scalar multiplication, then that 1/2 gets applied to every entry. So I end up with 10, 15, 8, and 12 as my final answer. Is that okay there?
And the determinant is 1 over the B8 and then times
So the inverse is 1 over the determinant of your matrix times the rearranged version of your matrix, where you do that row swap and then opposite swap. You know what I mean? So again, the formula was if A is the matrix A, B, C, D, then A inverse is 1 over AD minus BC times DA negative B negative C. So that was our formula for an inverse. Right, so that's what we're showing happening here, where they're opposite signs of whatever they were. So if B was 2, in the inverse it would have been negative 2. Or if B was negative 5, in the inverse it would be now positive 5. So the sign just switches. Is that okay there? Yeah. Okay. Tommy? Of course. Who's next? Anybody next? We did a lot. Caden? Which one? Are you talking about these matrix word problems, or are you talking about the story problems? Okay. You want to do 80? So 18 reads, you are running a hardware store that sells hammers, saws, and wrenches. The first customer ordered 7 hammers, 1 saw, 4 wrenches, and paid $100. Second customer ordered 2 hammers, 5 saws, and 6 wrenches, and paid $83. The third customer ordered 12 hammers, 8 saws, and 11 wrenches, and paid $240.50. What was the cost of 1 hammer, 1 saw, and 1 wrench? For your answer, include the system you solved and the solution. Okay, so how many variables do we have here? 3. So I'm going to use H, actually let's do all capitals, H, S, and W for hammer, saws, and wrench. You good with that? What's one equation we can write? Yep. Good. I agree with that. And another equation we could write is? Good. I agree with that. And what's the last equation we'd write? Good. So notice, oops. When I did this, I was very careful to make sure everything lines up vertically. So the H's all line up, the S's all line up, and the W's all line up. The reason I wanted to do that is because it just makes it that much easier to transfer this into a matrix on my calculator to solve now. So I'm going to solve this using the RREF. So I'm going to have 7, 1, 4, 100 as my first row. This is it. Like, you show me the system and then you're just going to write down your answer. Because this is supposed to be the part of the test where I can ask you some more questions where, like, we can just see if you know how to use the calculator kind of thing. So I wanted to be able to ask you questions that are really just involving you using the calculator. So on these questions on this whole page, I think the directions say all you needed to do was do the setup and then use the graphing calculator to finish it off. So here we would just say, like, hammers are $12, saws are $10, and wrenches are $1.50. So if you give me the system and you give me that answer, that's all I need. Is that fair? Okay. Zach?
Could you add up, like, piece the hammers together, and then equal that to all of them put together, and then divide the number of hammers by price?
No, because some of that price is coming from saws and wrenches, right? I mean, you could do like substitution or elimination to solve this system, but like, don't do that stuff by hand. Use the calculator to do it, right? Like, it's super fast. Madison. So, I mean, there's a parenthesis around it, but RREF isn't like a thing to multiply it by. It's an operation. So, like, you don't say that, like, I multiply by, I do 2 times square root, right? You'd say square root of 2. Type the matrix, close the parenthesis, and press enter. That's it. So just like it looks right here. So what I did is I went to the matrix menu, I went over to the math tab, I found the RREF command down at the bottom. I then went back to the matrix menu and picked my matrix that I was interested in. Just close the parenthesis at the end, only one of them though, and then just press enter. And it spats it out. Notice that the left-hand part is the identity matrix, where you have the ones down the main diagonal and zeros everywhere else. So what that tells you then is that these are just your answers, right? 1H plus 0S plus 0W is 12, or just H equals 12. Type. Of course. Madison, you happy with that? Yeah. Okay. Anybody else with questions here from this? Nancy? Can I do 10 real quick? Sure. That's just one of these example problems, right? Okay. So when we do matrix multiplication, what do we have to be worried about? The dimensions, right? The dimensions of our matrices have to match. So, for example, if I did like a 2 by 2, and I multiplied it by like a 1 by 2, that's not going to work. Correct. The inside parts of the dimensions. If I did this in the other order, would it be okay? Yes. So you have to make sure that you have the inside dimensions. But that's all. Just anything, like there's an infinite number of examples, you just have to have the dimensions not match up in the right way. Is that cool? Okay. And when I say specific, I just mean like put some numbers in something, right? Just like we did here. Like it doesn't matter what the numbers are, because the dimension is what matters, right? Okay. Did you guys have an answer for 11? Did you were able to figure that one out? What's the issue that we have to look for on 11? When is an inverse? When is a square matrix not going to have an inverse? When what? When it's 0, what is it? The determinant is 0. That's what you need. So this is just the equivalent of finding any matrix whose determinant is 0. So what's going to be easier to find a 0 determinant for? A 2 by 2 or a 3 by 3? Way easier for the 2 by 2, right? So what could give us a 0 determinant? Opposite of A. Well, what are the numbers that we need to put in here? Give me the... Okay, well that would be 4 minus 0 and 4 would be the determinant of that. So that's not going to work. Sure, because that's just going to give you 0 minus 0, which is 0. Right, how are we finding these? That diagonal minus that diagonal, right? So that's fine, sure. If you have one row of zeros or one column of zeros, that would work. But in general, like if the two numbers, like the two diagonals multiply to give you the same thing, that works, right? Or you could do like something like that, right? It's not hard to come up with like two numbers that multiply to give you the same thing, right? Everybody kind of see that? Okay. So that should be, once you know what you're looking for, it's easy to come up with a specific example. But yeah, a row of zeros or a column of zeros would work also. How are we doing here on time?